The title of the presentation today is A Layman's Guide to Warehouse Analytics. Our presenters are Justin Ritter, Director of Project Engineering, and Graham Yenny, a data scientist here at Lucas. My name is John Schriefer. I'm also with Lucas, and I'll be moderating the Q&A for today's session. Now, first, let's take a quick look at the agenda. So as the title suggests, our main goal today is to provide an introduction to the subject of analytics for non-experts. And our focus is on the types of information that analytics tools can provide in the warehouse or DC context. Justin is going to first provide a quick outline of the topic and also discuss why it has been difficult in the past for DC operations to get the analytical insights they need, in large part because of the operating systems used in the DC, primarily the WMS or ERP. The systems are not meant to support the analytics beyond the here and now. Justin is then going to provide a few examples of descriptive and diagnostic analytics tools for the warehouse that use data from execution systems to provide multi-site visibility and analysis that go beyond the typical reporting you would get from a WMS or an ERP. The last part of the presentation is going to focus on next-generation predictive analytics tools that use the power of the web and machine learning technology, not just to understand what has happened in the past, but to anticipate and predict resource requirements in the future. So with that, I'll turn it over to Justin Ritter.
Thanks, John. To get started, when thinking about data reporting and analytics, maturity models are often used to talk through the stages of sophistication organizations operate at. Most warehouse operators use different forms of metrics and KPIs to manage their operations, but the reporting tools we traditionally use in the DC are somewhat limited to answering questions around what happened or how are we doing this month or this week. So, at best, most DCs are operating on the left-hand side of this chart, with standard reports from the WMS, ERP, or other systems. In many cases, companies can't get this type of analysis directly from their existing systems, or they will rely on BI or other reporting tools that typically require IT resources to create and maintain. That type of reporting and analysis is commonly referred to as descriptive and diagnostic analytics. You can see the bullets along the curve around the different tools and stages within that. Many of you on the call are likely on this curve somewhere. But for many of the people we talk to, they have a lot of data available from those systems, but they still aren't able to get a broader view of their operations, such as a network-wide view across many DCs, or deeper historical insights into the data that would help in planning and managing the operations in the future. That is the realm of predictive and prescriptive analytics, the bigger bubbles on the right-hand side of the chart. So that's a 30,000-foot view of the evolution of reporting and analytics, but let me make it a little more specific to the DC. So with another view of the maturity model, we'll go beyond the theory and get to specific examples in the context of a warehouse, DC, or fulfillment center. Analytics is answering questions like, how are we doing, or how did we do this quarter? What are the trends that are occurring? Diagnostic analytics add a layer of analysis to the data to identify why your numbers look good or bad. For example, a DC manager might look at his scorecard for the month and see that his lines per hour have improved, but his perfect order shipments have declined because his order volumes are up 20% and his inventory accuracy is down. Today, that type of insight comes from people looking at the data using visualization tools. If you have the tools to give them the data in a form in which they can use it, that is commonly referred to as data-driven insights. Predictive analytics tools give managers an outlook for their shift, day, or week, and can help them make better decisions in the course of a shift. For instance, if I move 3 workers from one zone to another, will that be enough to get all my orders picked and shipped on time? Those are the types of questions that engineered labor standard systems can help you answer, but new predictive analytics tools using machine learning can give managers those kinds of planning insights without the expense of implementing or maintaining an engineered system, commonly using engineers to do time studies and maintaining data over the course of a year, in which case it gets stale over time. So now on paper, that all sounds great. We have the data, and most of us who are using a WMS, why don't we have more tools to help us get these types of analytical insights, whether historical or real-time? The fact is, analytics isn't easy. Yes, we have a lot of data, but today many operations people don't have access to the data in the way they need it or could use it. The typical WMS provides reporting, but it's a transaction system meant to manage operations. So they aren't meant to provide historical data or insight into the trends or relationships among data. For that, many people rely on Excel, or if you're lucky, you need an external reporting system. For instance, how do you pull in the timesheets for people and marry them to the transactional details of picks and material movements? I'm sure some of the people on the call have lived this nightmare in Excel or even in Microsoft Access, which is a common situation for operators. But we also have many more sources of data today, not just the WMS. In some cases, you could have an execution system, automation systems, all generating data and reports. Utilizing a work execution solution that Lucas provides can be integrated to all appropriate systems and unify all this data into one model to make it easier to accomplish these things. So the challenge then is to pull the data together and deliver the insights and foresight different people need at different times, whether they are DC managers, regional directors, or even supply chain executives who have responsibility for fulfillment, among other areas. Key technologies to address the analytics challenge. Storage today is relatively cheap and plentiful, so it's not a great challenge to replicate and store production data in the cloud or on-prem for analytics purposes alone. Likewise, processing power has grown tremendously, so it's not necessary to bog down production systems for reporting when you can essentially create an analytics system with more than enough processing power at a relatively low cost. The last two things, web reporting and visualization tools, and the machine learning tools address the people-related issues. In particular, in the past, companies relied on data analysts and other IT resources to develop and deliver analytics tools for use in the business. And in the realm of providing intelligence for business planning and optimization, machine learning replaces highly engineered models used to improve predictive analytics. So to tie this into what Lucas has been working on, we've been developing improvements to our current data visualization tools that we have today. In our existing platform, our Lucas Engage system provides dashboards for the supervisors managing the operation in real time, as well as providing historical context for data such as productivity graphs and details of associates working in our system. As a step above that, we've built a new enterprise analytics product that could sit outside our current installation, pull in and aggregate data from our work execution solution, and provide analytics to trend beyond what is visible in our Engage system. There's a lot of value for multi-site customers who run multiple instances of our solution and only have visibility of the data through Engage at one of the sites at a time. Now, as an operations leader, I can compare and contrast how my DCs are working. The example screenshot shows picking productivity at a site level, as well as total volumes in terms of number of pick lines and units over a certain period of time. This provides a high-level view across each site to understand productivity and activity, which is powerful by itself. The next example shows the same information trended with the details down to a user level. This can help ask some leading questions around variability and productivity, as well as how the sites compare day to day. Are there mixed changes that are impacting a certain site that need investigated? The user level details provide the ability to measure the curve of productivity within the DC. Is each operator managing their workforce properly? These types of dashboards take away the traditional time of collecting, combining, and building models to measure and provide valuable insights to drive actions for improvement or further review. This is also very valuable for companies without formal business intelligence platforms or data warehousing strategies. It's a quick win to provide visibility to help drive operational excellence that every operator is expected to deliver year over year. A common saying in business is, if you can't measure it, you can't improve it. Our goal is to provide a reliable and consistent way of measuring key performance indicators relative to the DC and fulfillment operations that enable operators to measure and become the starting point to making decisions, driving improvements off the data, what we were referring to as data-driven insights. So with that, I'm going to hand off to Graham to talk a little bit more about predictive and prescriptive analytics.
Thanks, Justin. So as we move up the maturity curve and talk about predictive analytics, I'm going to talk about predictive analytics specifically in the context of machine learning. So machine learning thrives on large sets of data, what we're calling big data, but there's kind of a bear trap in framing our problem this way. So if I were to say I'm going to collect all the data I possibly can in my operation and then hire a bunch of data scientists and have them tell me what's valuable in that data, we're kind of setting ourselves up for failure. What successful machine learning projects look like is there's a business use case. At the bottom of the slide, we list two specifically, workforce planning and dynamic slotting. It's typical to come up with a business use case and immediately say, okay, we do not have the data that we need to drive this use case. So with machine learning and big data, avoiding the bear trap is approaching the problem with a valuable goal in mind. So with machine learning and predictive analytics, we have a lot of benefits in applying these types of algorithms. They're consistently adapting, they're consistently improving over time. And we'll see later how this enables us to overcome some of the obstacles that engineered solutions have. So what is machine learning at a high level? We mentioned machine learning algorithms, which is a deep and rich and technical field, but machine learning, one step higher, is simply a process. We start with our historical data. We try to make a prediction using some algorithm that has learned from that historical data. We obtain some results, and if those results are great, we use them. If they're not, we continue to improve our algorithm until it reaches a level of performance that is useful for our application. So in the context of a warehouse, you can imagine an IoT-like system providing voice data, all this rich data happening, every activity one after the other. When we talk about things like workforce planning and dynamic slotting, we're talking about trying to see how long activities are going to take. In the warehouse, a lot of picking activity is dominated by travel time. Can we predict how long it's going to take a user to move from point A to point B and pick a certain quantity of those products? So now how do we angle machine learning to provide value over the status quo right now? So in the same case of slotting, let's look at what an engineered approach looks like. Typically, you'll have some system where you build a map of the facility, XY. You'll input some numbers to weight how important slotting is versus replenishment and so on. And then you run with that model and it works and the universe is good. And then something happens. I'm going to replace this section of racking. I'm going to replace it with a mod. Okay, so now I have a brand new facility. I make a cut through, something that changes the layout of my facility. How do I deal with the error? Option one is I don't. And I just live with the error built into the model and I continue going on as if the universe was good as before. Otherwise, I have to put in a change order. I have to go back to engineering, back to the drawing board. I have to change the software, write code, and I have to validate that code. The bottom line is with an engineered approach, in many use cases, you are continually having to throw money at the problem of adapting to a changing warehouse now and in the future. The machine learning approach goes from the other angle. It says, I'm not going to make any assumptions about the physical layout of your warehouse. I'm going to learn that. I'm going to basically learn the XY of these locations and learn how long it takes to go from one area to the other. You make a new cut through, that's great. The data will reflect that so long as the users are going through the cut throughs. So in the machine learning approach, we're looking at something that is proactive in its adaptation to changing environments in the warehouse. And that could be changing environments with product, space, layout, people. So why predictive analytics, and specifically predictive analytics with machine learning? I hope it's obvious at this point that by taking away a lot of the engineered speed humps that we have for solutions, is a reasonable, smaller cost. It doesn't cost as much to have an engineer change order to go and change the machine learning model. It is learning from your future data. It's using your data streams to continually adapt and improve itself. And compared to incumbent models, so if you look at something where, okay, I'm going to take the historical average and I'm going to project that into the future, if you make very long projections, if I'm going to say, okay, I pick 100 pick lines per hour, so over the next 3 months, I expect, X thousand of pick lines, and that's going to take me Y hours. You may be okay, but in the near term, in workforce planning, if I'm going to move user from this work area to that work area, and he's going to pick 100 pick lines, that model tends to break down in smaller forecasts. So we're able to provide more precise predictions and apply those to predictive and prescriptive analytics ultimately. So I'm going to turn it back over to Justin to bring us home with our summary.
So like we covered, analytics help the managers improve their KPIs. If you can't measure it, you can't improve it. Depending on where you're at in the maturity curve, you're likely sitting in the descriptive or diagnostic tools, meaning that you're combining current and historical data to analyze trends. And through our new enterprise analytics tool, we can provide some visibility into how your different sites are doing and provide those data-driven insights which take away valuable time that operators don't have to collect and analyze and build models to understand how their operation's performing. But beyond that, predictive analytics is the next big thing. Machine learning makes it applicable to all DCs, big and small, especially if you're using a system like ours, which is a work execution solution, which has the granularity of data needed to make these machine learning models really thrive. And at the end of the day, this all improves day-to-day operations and planning. So where do I need to move people, or where do I need to slot my product? It's a very compelling use case.
Great. All right. Thank you very much, Justin. So now we're going to take your questions. A couple of questions came in throughout the presentation, but if you have a question that you haven't sent to us yet, feel free to type it in on the Q&A box. And I'll read off the questions as they come in and give them to Justin or Graham to answer. Okay, so there are a couple of questions about the data that you would need for this. So first question is, would you use the same data for the historical analytics that you were talking about, Justin, as you would for the predictive analytics?
I think Graham and I can both answer that question. From my perspective, it is a little bit different. Typically for historical analysis, you only need to aggregate some of the less detailed information, such as the volume of transactions or the specific picks in an area. But with machine learning, as Graham will talk about, you need much more detailed data to build sophisticated models.
Exactly. It all depends on the use case. If the use cases align with the analytics and the prediction, then typically the data model will look very similar. But in many cases, a data model has to be custom tailored to that business use case, and the data will speak for itself and what needs to be included.
All right, actually another data-related question, and this is specifically for machine learning. So what data would you need for the machine learning, and where would it come from? Could you get the data you need from your WMS system, for example?
Right, so again, it depends on the use case. In the specific case of workforce planning, slotting, something where you're trying to predict movements and how long those movements take. Typically, the more garbage in, garbage out. The more resolute, the more accurate the data coming in is, the better. If you can know when a user exactly is commanded or otherwise instructed to go to the next location, and then you know exactly when they got there and exactly when they were picking, that's the kind of resolute data that you would want to have a much more precise result from a machine learning algorithm that would far exceed your expectations of a map solution or a historical average solution.
Okay. Next question is, real-world examples. Can you share any real-world examples?
Yeah, I'm happy to take that question. So we were talking about two things, so I'll parse them separately. The first one we talked about was enterprise analytics, which is a new offering for us. We're currently in beta right now, looking to release a formal product, and by Q1, we have 2 companies using it as a beta. The results, we're still collecting it, so I can't provide any real insights into that. Related to machine learning, we're also working on beta customers as well for our use of workforce planning. So this is providing feedback on where you should move people. Just taking a step back and thinking about what's the ROI or payback for doing any of this, right? So when you think about it, it's really the opportunity cost for your operators to spend the time to look at the data, build the models, collect the data, et cetera. That time is a cost. And then there's also the cost of doing nothing versus making an operational improvement, which will then hopefully improve the KPI that you're focused on. So with that, that's sort of the lens we're looking through in terms of a payback. There's always the soft benefits of having more visibility into your operation, but ultimately it just really determines what actions you're taking. If you're not taking any actions off the data, it's not really worth anything.
Great. We had another question about the multi-site analytics screens that we showed. Is there any benefit for that historical data for a single DC?
Absolutely. You know, there is a lot more value, I would say, for our multi-site customers. You know, running 10 DCs is sometimes hard to compare across apples to apples, how one DC compares to the next. You'll find that the site level managers will say their operation is a snowflake and a little different than the others, and they'll always use that to rationalize anything. But for a single site customer, there's value as well. So with Engage, we provide some in the moment visibility on how the operation's doing, as well as some productivity detail and some other things. But the value in enterprise analytics is being able to pull in different sources and trending that over time. So we typically store data for what I would call a 2-week period. With our enterprise analytics, we're hoping to extend that to provide trending, you know, for a longer period of time, so you can see seasonality, as well as if you had certain events in your operation occur, what was the impact? For instance, how many slot empty exceptions did I have with my pickers, which caused all kinds of churn and inventory control? That's just one example.
Great. Great. And I think you pretty much got a couple of other data-related questions, but I think you've answered them previously. So if there are no other questions, we've come to the end of the webinar. Like I said, we will be emailing out a link to a replay of the presentation, and we'll also provide a copy of the slides that we used today. And again, if you have any follow-up questions, feel free to email me. My email is there on the screen. And also check back for future Lucas webinars. We tend to hold these every 2 to 3 months. And we also have an archive of previous webinars on our website that you're welcome to view as well. Again, thank you very much, and look forward to seeing you on a future webinar.